perpendicular distance from a point to a line. So in that first theorem is the length of perpendicular from a point x1 y1 to the line ax plus by plus c equals to 0 is ax1 plus by1 plus c by root over a square plus b square. So for that I am taking P is a point x1 y1, the line ax plus by plus c equals to 0. This perpendicular distance I am taking as r. So it intersects the PQ is perpendicular to line ax plus by plus c equals to 0. So now we know previously we know the symmetric form. From symmetric form we may get the q value. By symmetric form so q is by symmetric form q is x1 plus r cos theta y1 plus r sin theta. So observe this one, q lies on ax plus by plus c. So it satisfies that one. So substitute there. A times of x1 plus r cos theta plus b times of y1 plus r sin theta plus c equals to 0. Simplify ax1 plus by1 plus c. Now this cos and tan sin forms. Ar cos theta plus Br sin theta plus c equals to 0. So in these two terms we may take r as common, by1 plus c r times of a cos theta plus b sin theta equals to 0. So you know requirement is a and b and x and y, but here cos theta and sin theta is there. So for that we need to convert these cos and sins in terms of a and b's. How it will be seen now. See, look at here. This PQ is perpendicular to ax plus by plus c. That slope of PQ is minus 1 times of slope of ax plus by plus c. So what is the slope of ax plus by plus c? Generally we know that one. The slope of ax plus by plus c equals to minus a by b. But PQ is perpendicular that one. So slope of PQ equals to minus 1 by minus a by b. So that means what? B by a. So slope of line is b by a means slope we can write tan theta. So tan theta equals to b by a. From that we may get the cos theta and the sin theta. So tan theta is b by a means b is opposite side and a is adjacent side. Then what is the hypotenuse by Pythagoras theorem? Square root of a square plus b square. From that what is cos theta formula? Adjacent by hypotenuse. A by root over a square plus b square. What about sin theta? B by root over a square plus b square. So these two values substitute here. So ax1 plus by1 plus c plus r times of a into cos theta, a by root over a square plus b square plus b into sin theta, b by root over a square plus b square equals to 0. So by simplifying these two, we observe a square by root over a square plus b square by root over a square plus b square. That means denominator is root over a square plus b square and numerator is a square plus b square. That is square root of times. Square root of a square plus b square whole square is a square plus b square. So we may write ax1 plus by1 plus c plus r times of root over a square plus b square equals to 0. So ultimately what we want? R value. So transpose this side, then that is equals to minus of ax1 by plus by1 plus c by root over a square plus b square. but r is the perpendicular distance, so it never be negative. So that writing modulus form. So modulus of ax1 plus by1 plus c by root over a square plus b square. This is the perpendicular distance from a point to a line. Right. Next one is distance between two parallel lines. So I am taking two parallel lines. See here, we know that one, the differentiation of parallel lines is only at constants, only difference. Remaining all we may write as it is. So I am taking two lines, that is ax plus by plus c1 equals to 0, ax plus by plus c2 equals to 0. So I want to find out distance between these two parallel lines. That is I am taking as d. So distance between two parallel lines means I am taking like this, the perpendicular distance from point P to this line. That is also distance between two parallel lines. The perpendicular distance from one point to the second parallel line is also we may get the distance between two parallel lines. So Px1 y1 and this line, this is the distance you know. Just only we will learn that one. That is perpendicular distance from a point to a line. So then we may write the perpendicular distance from Px1 y1 to ax plus by plus c2 equals to 0 is, so therefore d equals to modulus of ax1 plus by1 plus c2 by root over a square plus b square. This already we know that. So now coming to here, Px1 y1 is lies on ax plus by plus c. So is satisfying that one or not? Ax plus by plus c1 equals to 0. On that line, Px1y lies. So ax1 plus by1 plus c1 equals to 0. From this, ax1 plus by1 equals to minus c1 we may write. So substitute this value here. So d equals to modulus, in place of this one, ax1 plus by1 we may write c1. That is minus c1 plus c2 by root over a square plus b square. For modulus value I am taking common. You may write c2 minus c1 by root over a square plus b square also correct. Or we change that one, taking minus common in positive manner. So we may write c1 minus c2 by root over a square plus b square. This is the perpendicular distance from between two parallel lines.